So recall that the graph of a system of linear equations can be one of these three. In this case, it only looks like there's one line, but there's actually two lines, and they're directly on top of each other. So what does that mean? It means that your equations are identical. For example, this doesn't really go along with the graph, I'm just showing an example. So if two lines are graphed identical on top of each other, they're in essence the exact same thing. So where do these two lines hit? Because when you go to solve the system, you're really looking for where the two lines intersect each other. So if one line intersects the second line everywhere, we would say that these are infinite solutions. There's a ton of them that will work. Now let's take a look at this one. We've got two completely separate lines, but if you look at them, they look parallel, and that's because the slopes are the same. So two lines with equal slopes. But notice that they're completely separate from each other. So in that case, here's just a random example, 2x plus 8, and we could have y is equal to 2x minus 4. It's these that are the same, but not these, which will then cause two separate lines, both going in the same direction. So where do these two lines hit each other? Never. So in this case, we're going to say no solution. And then take a look at these. Okay, so if you take a look at these two lines, they are going in different directions, which means they're eventually going to hit. And they're going to hit in this spot right here. And how many times will they intersect each other? One time. So we're going to have one solution, and it is that exact coordinate that you see them hitting or intersecting at. How do the equations look? Two lines with different slopes. And so we're going to delve a little bit further into these. So substitution and elimination, we're more familiar with these. You did this quite a bit in Algebra 1. So substitution, one of the equations need to be solved for, y equals or x equals, it doesn't matter. In this case, they happen to both be solved for y equals. So what we're going to do is we're going to substitute one of the expressions after the equal sign into the other equation in place of the letter y, because see how it says that y is equal, it is the exact same thing as 3x, so we're going to put 3x in its spot. And if you do the substitution correctly, you should only have one type of variable. In this case, I have all x's. And now we're just going to solve normally, so we're going to add 2x to both sides. And then you're going to divide by 5. And you're going to get x to equal 3. But once you're done with one variable, remember it's a system, we have to have the x and the y. We're going to go back to one of the original ones here, and we're going to pick, it doesn't matter the equation, just pick one. I picked the top one. And you're going to plug that answer into the x spot, because that was my answer for x. So now I get y is equal to 9. So my solution is going to be the coordinate 3, 9, which means if I graph them, they would hit at that coordinate 3, 9. Okay, the other way that you can solve a system of linear equations with two variables is this elimination method. I choose elimination whenever they're in standard form. And our goal is to get either the -5 and 2 to be the exact same number but opposites of each other, like -5 and 5, or 2 and -2, or you can deal with the numbers in front of y, it doesn't matter. And in order to do that, you might have to multiply one of your entire equations by a number to get it to match up. So let's just take a look at this top one right here. So let's say that I want this to be multiplied by 2, and I want this to be multiplied by 5. Before I go through and double check, let's look at this. 2 times -5 would give me -10, and then 5 times 2 would give me 10, so those would be opposites already. So I get -10x plus 4y is equal to 18. And then if I multiply everything down here by 5, I'm going to get positive 10x, negative 15y, and then I'm going to get negative 95. Once they're set up properly, you're going to add straight up and down, and that will eliminate an entire variable. And then we're going to solve for that variable, so we're going to divide by -11, and we get y to be 7. And then the same way we finish off with substitution, we're going to take either one of these, it doesn't matter. I'm going to pick the top one. And since the answer for y is 7, I'm going to plug 7 in place of this y here. So 2 times 7 is 14. And now I'm going to keep solving. I'm going to subtract 14 from both sides. And that will give me negative 5x is equal to negative 5. Divide by negative 5, and I'll get x to be 1. That means my solution to this equation is going to be 1 comma 7. And again, if I graph these two, they would hit at that 1, 7 spot.